Good morning, guys. And today our topic is RVDT. RVDT stands for our Rotary Variable Differential Transformer. Okay, so it's a transformer which can measure the rotating displacement or the angular movement of any particular displacement by this RVDT. Now we can see this is prior to RVDT. We should also know the construction of LVDT, and now today we are also going to discuss the LVDT, because LVDT and RVDT are the same. Uh, so we are going to start. That is, look. First, we are going to start. This is LVDT. LVDT stands for linear variable differential transformer. Okay, and now RVDT. RVDT stands for rotary. This is for variable. This is for the variable. This is the differential transformer. Differential. This is transformer. Transformer. This is linear variable. This is differential. This is transformer. So these are the transducer. So we have to know what are the transducer. What are the transducer? What are the sensor? Look, in instrumentation and measurement and field, we need to measure some physical phenomenon or physical quantity, just like temperature. This is temperature for a heated body or anything. It may be measured by the thermometer, but thermometer is only human can read this. But whenever this is a question for the controller, whenever question for the digital unit, digital display, whenever it is the purpose for the recording, then we need some physical quantity, and we need to convert it and the electrical quantity so that we can measure it and we can store it as a data. Thermometer only can show uh, for up to the time whenever it is at the contact. Another physical quantity we can say that that is flow or the flow rate. Say water is flowing or any things is flowing through your pipe. This we need to know the flow rate or the flow of this water. Means flow rate means flow in current in speed also, because it is storing in a tank. If this is very high flow, then within few seconds it will just overflow. So we need to control it. That's why we need to know the flow. Humidity. This is also a physical quantity, but we have to know it, we have to measure it. In our modern smart irrigation, we also control the the moisture, and if we need to control this moisture, just 1 minute. So these are the physical quantity. These are the physical quantity. But we have to measure it. Measure means we need some perfect sensor so that it can sense the change of temperature. Now it is coming to the point of change of temperature. Change of temperature. Change of flow rate. Change of humidity. So we need to measure it. So we need perfect and particular sensor so that sense the temperature. Say in this case, perfect sensor means it may be resistance type. So it is called RTD. RTD is the resistance temperature detector. TC, thermocouple, etc. Bimetallic thermometer, bimetallic strip. It is on off used for on off purpose. Okay, change of flow, it may be so many flow rate measurement is there, just turbine type flow meter, uh, ultrasonic flow meter, etc, etc. Humidity, this is also applied for the humidity sensor. This humidity sensor is made of cadmium sulfate, and it can sense the humidity. As per the humidity, its resistance is also changed. So in this way, and so many physical quantity, not only this, because in our industry we need so many physical changes of this, uh, to measure all of this parameter so that we can control smoothly our process. So we need some sensor, we need some transducer. So sensor is a particular device which can sense any physical quantity, and it will produce some physical signal, or it may sometimes it may changes any electrical quantity also. So sensor and transducer are just like a two sides of a coin, because sometimes sensor are attached with the transducer itself. Sometimes we need to add some sensor which sensing body can sense the physical quantity and produce some physical measurable quantity, and then a transducer can measure and it's convert any physical phenomenon into a electrical phenomenon. So if I go for this block diagram representation, if we go for this block diagram representation, then we can see this is a sensor which can sense any physical quantity. This is physical quantity, and it is also convert a physical measurable quantity. Then it is going for the transducer, which convert any physical measurable quantity or any physical quantity into a electrical measurable signal. Then it will go for the amplification part. then it will go for any amplification part, then it will go for the signal conditioning. Then it will going for the microcontroller unit. This is a microcontroller unit for the, or the, you can say this is the data processing unit. Then one part is going to the controller and another part is going for the recorder or display unit, digital display unit. So this is the scheme for a instrumentation where we can measure any physical quantity into a recordable data, convert a recordable data so that we can use it, and it sends to a controller so that controller can control the process as per this is measurement. If we couldn't produce this perfect measurement, then controller also gets the error data, and then it also control the process and which the output produces the error output. So this is the schematic diagram. Now we are going for the particular transducer, that is LVDT and the RVDT. Just erasing these things. Now, first we have to know what, how, and why. What, how, and why. What means as about the diagram, about the statement, about the description, construction also. And how means working principle. How means working principle of the LVDT or the RVDT, and why. That is means application. Statement, construction. How? How means working principle. How means working principle. So if any object come to you for your study, or as a subject to be know, for a subject for the your knowledge, then you asked what, how, and why, then you can know everything and just remember it. So this is the easy way for remember or to know the any instrument or some any topic also. Okay. So LVDT stands for linear variable differential transformer. So it's a transformer. So this is measure the linear variable displacement. So from this name, we can, if we ask what, then it will answer LVDT is a transducer which can measure any linear variable displacement. So LVDT is a transducer which generally a transformer, and this transformer can measure any linear variable displacement. Okay, so this is the question and answer. So from this answer, from this acronym, we can understand the name. Then how it is working and what is the construction? You can see the construction is just like this. So it is a transformer. We all know what is the transformer, what is the construction. Just I am drawing this. Look, this is the transformer, this is the primary side, and this is the core. This is the core. So this is the primary coil and this is the secondary coil. Say this is S1 and this is S2. Look, this secondary is divided into two halves. First one half and second this, and this is mutually opposite in direction. The connection is like this way so that they are mutually in opposite direction. So this is the core. This is the core. You can see this is. Look here, it is a plunger, or you may say this is some axle is there, which which is displacement, and this displacement is measured by this output signal, electrical signal. Say if I put some scale over here, if I put some scale over here, and this can be displaced. If anybody which can displace over here and there, and it will be measured by this uh, LVDT. Okay, so what is the working principle? Working principle is just like this. This is primary, this is core. So when core is at the S1 position, then look, from primary to secondary, the through core induction is possible. So it will, flux linkage is occurred at this core, then also flux linkage is occurred at this S1 core. So S1 only get induced. It produced use EMF E1, because S1 is giving, so say S1 is given E1 and S2 is given S2 is given the E2. So ultimate output is E output is E1 minus E2. So at that case one, core displacement, due to core displacement, core is at the position of S1. So it will only the E1 is induced and E2 is 0. So E1 is E output is the E1. But if it happens, but if the core is displaced and come to the position of the E2 position, say it is displaced over here due to some pressure, due to some any displacement of this object, then core is come to the position over here. Then what happens? Then what happens? Then then ES2 is induced through this core. because from primary only flux linkage is occurred at the core, and this core also linkage the flux with this S2. So at that moment the E2 is getting EMF, but U1 not getting any EMF. So E output E output is E1 minus E2. Now E1 is 0 and E2 is minus. So we get the minus displacement. One means it is going to the negative displacement for the electrical signal. And what happens if the core is at the between E1 and E2, S1 and S2 position, then what happens? Look, core is at the displaced such a way it is covering S1 also, S2 also. So what happens from primary to secondary on same amount of EMF induced, same amount of EMF is induced. So E output is E1 minus E2 equal to both are same, that is 0. So in this way, LVDT we can measure the positive direction displacement and the negative direction displacement and the position of the 0, and in between this we can measure any direction. It is the working principle of LVDT, and now some specification we need to know. That is, LVDT is normally a transformer. RVDT also a transformer, just like same. Just this is the rotary type, but we need to know how much amount of power should induced produced. That we need to provide 1 to 24-volt AC. Okay, this is the operating. This is the input power, and what will be the hertz? It may be given 50 hertz, but 50 hertz is very less because this transformer is so less in number of turns that is not work properly with this 50 hertz, and the range is input range is 50 hertz to 20 kilohertz. Okay, but in our laboratory kit or general purpose kit we are using 4 kilohertz. It is produced by some electronics device, electronic circuit also. And what will be the output? Generally uh, it is divided into 12 12. So it will, if we provide 12 volt, then we'll get 24 25, so 11 12 12 two parts. And now what is the measuring area? It can measure 100 micrometer, 100 micrometer, that is plus minus plus my plus 100 to negative up to 25 centimeter, 25 plus minus 25 centimeter. This is the working range. And now this is the LVDT. And if we go for the plotting of displacement versus voltage, displacement versus voltage, then we get this like of graph. Okay, so this is the linearity range of the LVDT. Generally we are getting 25 semi, and in our laboratory purpose we can generally use plus minus 10 millimeter, because 10 millimeter slide calipers and other micrometer device are available. That's why we are using in our laboratory purpose. You can see 10 millimeter range we can use it, but in your industry then it is applicable more. And now it is the application. Application is generally done many types, many area where we can measure the displacement in the small range. But specifically, very interesting application is there where the thickness control is there. So this is the rotating roller, and this is a rotating, this is the fixed roller, and this is coming ups and downs, so that we can measure. Say this is a metal sheet, this is, it may be paper pulp, so we need to control the thickness of the paper, and then we can control the ups and downs of the roller, and so that it can look here the thick thick area is coming, but whenever passing through this roller it became it's very small, its thickness. In this case, LVDT is used over here so that it can measure core is there and core is connected with this position, and so that it can measure the ups and thickness of this output, and as per this output it sends to the controller then control the ups and downs of this roller, so that we can the control the thickness, and so many areas where the LVDT is there. And RVDT just like same, but it is round, say it is rotary shape. Say this is primary, and this is secondary. This is secondary is there, and core is just like this. Core is just like this. Core is just like this. It is rotary. It is coming over here. So S S1 is charged. It is coming over here. So S2 is getting EMF. It is whenever it is at the between, then it is getting zero. So the range of this RVDT is plus minus 80-degree electrical angle. Okay, so 80-degree electrical angle, it is going to move. It is measurable. Okay, thank you guys. If you have any question, you may ask me. Otherwise, I am going to stop here. Uh, okay, stop here for today. हेलो, हाँ बोलिए।